The last lesson in chapter 6 is inequalities for two triangles. We're going to take the theorems that we learned from lesson 6.4 and apply them also with a few theorems from today. And we can apply them with two triangles as well. The first theorem is the side angle side inequality theorem states if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. Essentially what that means is if I know that two sides of a triangle are congruent to two sides of another triangle, it doesn't necessarily mean the angles are congruent like we've been used to in the past. So if this angle included here is smaller than this angle included here, the opposite side in green is longer with the included angle. We can take a look at that and prove it based on the fact that if I have triangle DEF and I move it up, you can see that B and the dotted auxiliary line would also represent the segment DE on the other triangle. Well, obviously if I increase the angle at vertex B and increase the angle which would be represented by E, angle ABC is greater than angle DEF. Therefore, looking at the segment, we have this whole additional piece here that would be represented by DE in the other triangle. Therefore, all this proves is that AC is longer than DF. Sort of the converse of that would take the side-side-side inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, but the third side of the first is longer than the third side of the second, the included angle of the first triangle is larger than the included angle of the second. So if we know that two triangle sides are congruent to the sides of another triangle, but the third side is longer, the angle opposite the third side is larger than the angle opposite the second side. Since this is a pretty proof-heavy lesson, see what you can come up with as a given for as a deduction from the given D is the midpoint of AC and the measure of angle 1 is less than the measure of angle 2. Here's what we came up with. In the two triangles, BD is congruent to itself, and then you know that AD and CD are congruent because D is the midpoint of AC. From there you could use the side angle side inequality theorem to state that BC is less than AB, because if angle 2 is greater than angle 1, then the side opposite angle 2, AB, must be longer than the side opposite angle 1, which is BC. Hit pause and answer questions 1 through 6 on your worksheet now. Continuing with proofs, we're going to write a two-column proof this time. Given BC is congruent to DC and AB is greater than AD, we're trying to prove that angle 1 is greater than angle 2. See if you can follow along with this logical reasoning. We obviously have that BC and DC are congruent, and AB and AD, AB is greater than AD. From there, we can use the reflexive that AC is congruent to itself. And then from there, the only thing that we really need is the conclusion statement, because if we know that all three sides have a relationship where two sides are congruent and the third side is greater than the other side, then that we can conclude that angle 1 is greater than angle 2. The side that we're talking about is AB being greater than AD. The really only step that you needed to prove was that AC was the reflexive piece to connect the two segments as congruent. Another proof. SP and PQ and QR are all congruent. Our job is to prove that SR is greater than SP. Using the given, we're going to conclude that the measure of angle 1 is equal to the measure of angle 2 using the isosceles triangle theorem. After that, we're going to say that the measure of angle 3 is greater than the measure of angle 1 because the exterior angle inequality theorem, which states that any exterior angle is greater than any one of the two remote interior angles. We could then substitute angle angle 2 with angle 1, making angle 3 greater than the measure of angle 2. SQ is equal to SQ as a reflexive piece. And finally, SR is greater than SP with the side angle side inequality theorem. Take a second and finish the rest of the worksheet, with including number 13 as your proof at the bottom, and have that ready for tomorrow.